All right, so this section is 7.3, and we're talking about the basic counting principle. So when we're trying to add up for like probability, our denominator, we're trying to add up how many possibilities there are. We need these basic counting principles. They help us count things up. Like, for example, if I'm in charge of an area code, how do I know how many people I can give a phone to before I need a second area code, right? Those kind of things we're counting up. Also, I love gambling examples with probability and these counting principles. Like, how likely is it for me to win some kind of a gambling game, right? Okay, so look at what I have here. It's 7.3 basic counting principles. So I want you to think of multiplying the ideas together. So I would like a little side note here, right? Where you multiply the, how do I want to say it? And the options, multiply the, oh goodness, ways. Nah, I'm trying to think through the problem. Let's see what the choices. That might be a better way. I don't know, choices together. So this is called your fundamental counting principle, where we multiply them together, okay? So let's look in this little box, and we have an addition property. So if we're unioning together two sets, okay? And we can look at those two sets with the Venn diagram if we want. We have set A, set B, and we're trying to add up how many are in A and B. We have to be careful of that overlap, that middle section, and we cannot count it twice. So this right here is trying to remind you of that. So we need to count total A, total B, and be careful of double counting your middle. So it's saying if you count all of A and all of B, you have to subtract that middle off. Okay, or be careful how you count, one or the other. And then this one is saying, if set A and B are disjoint, they don't have anything in common. So the drawing of those would look like this, right? A, B, they're disjoint. They don't have anything in common. Then you would just add them up. But you have to be careful if they have something in common that you're then taking off that common area. So let's look at some counting principle examples. So problem A says, determine the number of ways that the elements in the set ABC can be arranged by listing your outcomes. So this is the most tedious way that we don't really want to think about it. How many ways can I put ABC, these three things, in order? Well, we can keep it in the same order. We can do ACB. We could do CAB, CBA. Oh goodness. We could do BAC, BCA. I think I got them all. 1, 2, 3, 4, 5, 6. I think I got them all. Well, B says, all right, use a tree diagram. So we could pick A, we could pick B, we could pick C. If we picked A, we then could go, well, we can't do A twice, so we could go B or C. Oops. And if we picked B, then we could go C or A. If we picked C, we could go A or B. I don't really love the tree diagram for this one. And AB, I still have a C here, AB, ACB, BCA, B the CAB, CBA. I get 1, 2, 3, 4, 5, 6 ways still that way. The tree diagram I like better in a different situation, but there we go. And determine the number of ways that an element can be arranged using the multiplication principle. So for C, we're like, okay, there are 3 options for the first one. Okay, now how many options do I have for the second one? Well, I used one of them. Okay, and then I have 1 left for the third one. And my tree diagram follows that 3, 2, 1. So we could get 6 total. Now, when we do the count principle, we have 3 options for the first one. We could pick A or C. Well, we use that first one, so then we only have 2 options for the second one and 1 option. Sometimes those options will stay the same and sometimes they will count down. Very tricky when you read the problems on which is which. Okay, Carol picks out a birthday gift for her younger brother and decides to have it gift wrapped by the store. So she has a choice of 3 wrapping, plaid, stripes, and checked. She must then decide on a ribbon. She has 4 choices. Okay, they're missing a choice on here. 4 choices, and then they list 3. So we'll add blue. Determine the number of ways that Carol can have gift wrap by using a tree diagram. So we're going to do a tree first. And we're like, okay, so we have paper, 3 options. So 1, 2, 3, and it was plaid, stripes, and checked. Okay, and then she has to decide on those ribbon, and the ribbon went red, green, yellow, or blue. All right, and then if I pick, this one's a little bit different. If I pick striped, I still have the option of red, green, yellow, or blue. Okay, it didn't count down. And this one either. So red, green, yellow, blue. So how many options do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Each full branch represents an option. So there are 12 possibilities, 12 choices. Okay, B says, determine the number of ways that Carol can have the gift wrap by using the multiplication principle. So for part B, we're like, okay, well, we have 3 choices of wrapping and 4 choices for the next one. So we just times them. See how I was trying to come up with that word for choices or possibility? We just times them. So a tree diagram to me is way more tedious. And what if we're thinking about a coffee shop where I have, 10 options of flavoring, 3 options of milk, and 5 different kinds of coffees? Like, I don't want a tree diagram of that because it's going to be 12 times, what did I say? 3 times 5, right? So I think I said 3 milks, whatever. So we times all 3 of those together. It's going to be huge numbers. So a tree diagram really only works when it's really a small amount. So problem 3 says, Joe and Fred go out to dinner at a local restaurant. On the menu, they have 5 different salads, 10 different entrees. Joey is not feeling very hungry and decides he will have either a salad or an entree. Fred, however, is ravenous and he decides he will have both a salad and an entree. How many choices does Joe have if he chooses a salad or an entree? Okay, so he's gonna, if we go back up to the beginning and we think of the symbol, just so we know, we're thinking of or, right? Disjoint sets or, well, this one or that one. So we're just going to add those together. Okay, so I always think like this one or this one, we're adding. Okay, and it's more of timesing. So we have, well, how many do we have? 5 different for the salad, and we're going to add that to our entree. So he has 15 different choices. So or plus, and times. Okay, how many choices will Fred have if he chooses a salad and an entree? So he has 5 different salads and 10 different entrees. So he is going to have 50 choices. That seems wrong, but think about it. If I did a tree, he could pick any of those salads. 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. And then each salad, he would have 10 options here, right? 3, 4, 5, 6, 7, 8, 9, 10. I totally can't draw that. So we're going to have 10, 10, 10, 10, 10. It doesn't matter which salad you pick, you still have 10 other options. So that gives you 50 different ways to choose your dinner versus only picking one. Natalie and Maria, I don't know where the N came from when I said Maria, they go shopping for blouses and capris. Oh my gosh, this is old. Do people still wear capris? I mean, I don't know. I'm making this video in 2023. Maybe they're coming back. Natalie has just received her paycheck and plans to buy both a blouse and a pair of capris. Maria has to make her car payment out of her paycheck and can only afford to buy a blouse or capri, one or the other. The store they like to shop at as 7 styles for blouses and 9 styles for capris. Blah blah blah. Okay, let's look at Natalie. All right, so Nat, her option, what did we say for Nat? She just received her paycheck and she's going to buy a blouse and a capri. What do you do with those two numbers? And what do we do? Times. So we had 7 blouses and 9. So 7 times 9, 56. Am I right? Sure hope so. And then for Maria, she is going to do the or. So what do we think for the or, right? Oh my gosh, 7 times 9 is 63. You're probably laughing at me. I can't ever remember my sevens. It's proof that you don't have to memorize things and still do math. That's hard. Before chemo, I actually could think of it. I'm going to be honest. After chemo, I can't think of everything that I want. Okay, there's my rant for I'm alive, but it is annoying that it kills part of your brain. So Maria, she chooses one or the other because she's more broke. So she has 7 plus 9. So she has only 16 choices. So Nat gets 63 if you do your math right. And Maria only gets 16 choices. Okay, last, I think this is actually, no, 2 more. So a survey was done by a local humane society at a shopping mall. The survey asked 200 shoppers if they owned a cat or dog. The survey found 80 people owned a cat, 55 people owned a dog, 23 people had both. How many people in the survey either owned a dog or a cat? How many people owned a dog but not a cat? So when I see something like this, I do like to think Venn diagram, and I'm going to do it in a Venn diagram also because some of your homework has that, and I want you to think about that. So it really is good to do a Venn if we have crossover. So we have doogies and we have kitty cats. I have a doogie sitting right beside me because I'm working from home today. So it says the survey asked 200 shoppers. So in the whole thing, you have 200 in the universe, like the whole thing, right? And the survey found 80 people owned cats. So that entire circle is going to have the cats is going to be 80, and 55 people all owned dogs, and 23 people owned both. So we're going to put 23 there, and we're going to think about this. So 23 people owned both. Well, if 80 people owned cats, right, then you have to subtract those numbers to get what would be in this category right here, because this is where they both are, which it has to give us, or you can add and see how many over 200 you are to see how many are in there. So I could go, well, this one doesn't give us the outside number. Some of the problems might give it to where you add up all the universe, and this one doesn't tell us how many owned none. And then you could see how many extra by how many were above the 200. So you could have a problem like that also. But we're going to take 80 and we're going to subtract 23 and get 57. And so oops, that was cats. I apologize. 57 cats. And so we can see that the 23 and the 57, that whole cat circle added to 80. So same for the dogs. 55 minus 23 is going to give me 32. So I'm going to have 32 over here so that whole circle will then add to 55. So a survey was done by, survey 80 dogs, 23 cats. How many people in the survey owned neither a dog or a cat? So now I can add those up. So 32 plus 23 plus 57, that's going to get us how many total were in the dog and cat. So 32, 23, and 57 is a total of 112. Okay, and then minus 200 is going to leave us 88 people because all of these have to add up to the 200 universe. Okay, as we surveyed 200. So we got an answer of 88. How many people owned a dog but not a cat? Right here. Okay, so these are our two answers that it asked about. It could ask this one. I mean, it could ask other things as well. Okay, last question. A survey was done on a college campus to determine how many students owned a cell phone. Everyone? Okay, of the 140 students surveyed, 95 students owned a cell phone, 65 students had a landline. I think this is definitely an old question. And 25 students had both a cell and a landline. How many students surveyed had neither a cell phone or a landline? So I'm going to do a Venn diagram of this one too. And we're like 140. So we know our universe has to add to 140. And we have cell and we have landline. Okay. And we had 65 students had a landline. 25 had both. So we do have the middle again on this one. And 95. So we're going to take our 95 cell phone and we're going to minus off that 25 in the middle. And I'm going to get 70 only had a cell phone and not a landline. And then in the landline, we had 25, no, 65 students had a landline. So 65 minus 25 is going to give us 40. And so we have 40 people that only have that landline. So then how many total is that? So what is the 70 and the 25 and the 40 going to add to? So 70 plus 25 plus 40 is going to give me 135. So I have 5 people left that did not have a phone at all. I actually think most people, there are a group of people now that are going back to like no phone, but goodness gracious, I use my phone for everything. So I'm definitely not one of them. Okay, so these were a couple Venn diagrams, a couple where you have to use the multiplying your possibilities together, okay? And then a couple where you possibly could use a tree diagram. All right, let me know if you get stuck or have any questions.